Hello, good morning to all of you. Am I audible clearly?
Yes, sir.
Yes, sir.
Okay. Just tell me what was the last topic covered in your class? Hello? Last week.
Inverse hyperbolic.
Yeah?
Inverse hyperbolic.
I could not hear it. Can you repeat once again?
Inverse hyperbolic.
Inverse hyperbolic. Okay. And after that, in the afternoon, inverse hyperbolic, Yogesh sir has taught in the morning. What is taught in the afternoon? Students? Hello? Hello?
Yes, sir. Logarithm of complex number.
Logarithm of complex number was taught or not taught?
Taught.
Okay. So that means what you are suggesting me that your exercise 24 was completed. Hello?
Yes, sir.
Okay. 25 is a self-study topic. Convergence of sequence and series was taught or not taught? Hello? Students? Was exercise 26 covered or not covered?
Fully not covered, sir.
Fully not covered. Okay. Till where it was covered? Okay. Or are they saying it was taught, but you repeat once again? Okay, no issue. So I go to the convergence of series. That will be fine.
Yes, sir.
I am going to exercise 26. There are two tests. Okay. Is the screen clearly visible to all of you?
Yes, sir.
Okay. Thank you. So let us come to this exercise 26, which is convergence of series. Okay. What is the meaning of convergence of series? Anybody? Anyone? What is the meaning of convergence of series? Hello? See, you all know that 1 plus x square plus x cube x raised to 4 and so on. It goes to infinite. Now this is a series which converges to 1 upon 1 minus x. Hello?
Yes, sir.
Yes, sir.
This is taught to you as this is a geometric progression. So sum of all infinite term is 1 upon 1 minus x. But doesn't it look sometime amazing that how it is possible that I'm adding 1 plus x square plus x cube plus x raised to 4. There is infinite term I'm adding in this 1, and this entire term is going towards this finite value. Hello?
Yes, sir.
Yes, sir.
So this should be thought. So this should be given a thought that how it is possible that when I'm adding these infinite term, it is going towards a finite value. It doesn't happen always. Under certain condition, this happens. Okay. Hello.
Yes, sir.
Now, when this happens that these infinite term I'm adding and I'm getting a finite term over here, we say that series is convergent. Series is convergent. Fine. But it may happen that if I'm adding, like if I add 1 plus 2 plus 3 plus 4 up to infinite. So this will be limit n tending to infinite, n into n plus 1 by 2. Hello?
Yes, sir.
Barabar na? Is everybody with me? What I'm writing?
Yes, sir.
Yes, sir.
And now this, if I calculate, it is going to be infinite.
Sir, minus 1 upon 12 होता है.
क्या minus?
Minus 1 upon 12 होता है.
क्या कह रहा है? Minus 1 upon?
Sum of all integers. वो वाला रामानुजन वाला सीरीज.
अच्छा, रामानुजन जीटा फंक्शन की बात कर रहे हो. चेक करो once again what you are talking. Okay, so this is limit n tending to infinite, n into n plus 1 by 2. This is going towards infinite. Now, if this is going towards infinite or going towards minus infinite, we say the series is divergent. Okay, hello? Hello?
Yes, sir.
Now there are the series like 1, minus 1, plus 1, minus 1, plus 1, minus 1, plus 1, minus 1, and so on. Now, in this series, if I'm adding even term, it is 0. If I'm adding odd term, it is 1. So this series is like, it's not going towards a fixed value, neither convergent nor divergent. Now, this kind of series is called oscillatory. Oscillatory series. Fine? Hello?
Yes, sir.
Okay. Now, कोई सीरीज कन्वर्जेंट है या डाइवर्जेंट है या ऑसिलेटरी है, ये आप सीरीज को देख करके डिसाइड नहीं कर सकते. Okay, there are some tests which a series, if it follows, okay, then we can say it is convergent or divergent. Okay, so there is first test called D'Alembert ratio test. Now, D'Alembert ratio test says if, now the generally series is represented by this sigma un. Sigma un, n is 1 to infinite. Okay, is an infinite series. Then if n tending to infinite, un plus 1 upon un. If n tending to infinite, un plus 1 upon un is equal to L. N tending to infinite, un plus 1 upon un is equal to L. Then if L is less than 1, then series is convergent. If L is more than 1, then series is divergent. Third, if L is equal to 1, then test fails. तो करना क्या है, ये जो तुम्हारी सीरीज है इसमें आप n+1 टर्म ले लो इस सीरीज का और n टर्म ले लो, उन दोनों का रेशियो लो. हेलो?
Yes, sir.
And find what is this ratio when n is tending to infinite. If that ratio when n is tending to infinite is L, and if this L is less than 1, we say that series is convergent. If this L is more than 1, series is divergent. If L is equal to 1, then this test fails. Now, when the test fails, that does not means we can conclude the series is divergent or convergent. In that, we say that this test is not applicable. Clear?
Yes, sir.
Okay, now let's go to exercise. Exercise 26. That's what we are dealing with. Yeah. So somebody please narrate the first question.
Test the convergence of the test for convergence of the series.
Test for convergence of the series
whose nth term is n square upon 2 raised to n. Whose nth term?
Whose nth term? Acha. Whose nth term is
n square upon 2 raised to n.
N square upon
2 raised to n.
4 raised to n.
2
raised to n. Okay. So nth term of the series is given to you n square upon 2 raised to n. So n plus 1th term will be what? N plus 1th term will be n plus 1 whole square upon 2 raised to n plus 1. Now un plus 1 upon un is n plus 1 whole square upon 2 raised to n plus 1 upon n square upon 2 raised to n. This implies n plus 1 whole square upon n square 2 raised to n upon 2 raised to n plus 1. Barabar? Hello?
Yes, sir.
Now limit n tending to infinite un plus 1 upon un is limit n tending to infinite n plus 1 whole square upon n square 2 raised to n upon 2 raised to n into 2. Fine. These two are eliminated. Now limit n tending to infinite. This is 1 plus 1 by n whole square into limit n tending to infinite 1 by 2. This 1 by 2 will remain as it is. This is 1. into 1 by 2. That is 1 by 2. And now this value is less than 1. Implies that series is what?
Convergent.
Series
Convergent.
is convergent by D'Alembert test. Clear?
Yes, sir.
Okay, let's go to the next question. Please, someone narrate.
Discuss the convergence of the series.
Okay, discuss the convergence of the series
Summation n equals to 1 to infinity.
n is equal to
1 to infinity.
Mhm.
X raised to n minus 1
x raised to
upon n into 3 raised to n.
n into
3 raised to n.
3 raised to n. Okay. Now in this, my nth term is x raised to n minus 1 upon n into 3 raised to n. And n plus 1th term is x raised to n upon n plus 1 into 3 raised to n plus 1. Fine? Hello?
Yes,
So
sir.
un plus 1 upon un is x raised to n upon n plus 1, 3 raised to n plus 1 upon x raised to n minus 1 upon n into 3 raised to n. So that is x raised to n, n into 3 raised to n upon x raised to n minus 1, n plus 1 upon 3 raised to n plus 1. Now limit n tending to infinite un plus 1 upon un is equal to limit n tending to infinite x raised to n, n 3 raised to n upon x raised to n minus 1, n plus 1, 3 raised to n plus 1. Now this will cancel one power. 3 raised to n will also get cancelled with this. Now limit n tending to infinite. This x raised to minus 1 is remaining, so that will go to the top. By 3 raised to 1 is remaining, so by 3. And 1 upon this n, if I take n common from this factor, I can write it 1 plus 1 by n. So this is ultimately will become x by 3, 1 upon 1 plus 0. So what I get is x by 3. Clear?
Yes, sir.
Now, I do not know what is x is. So my answer will be dependent on what is x. So now, if x by 3 is less than 1, that means x is less than 3, then series is convergent. Okay. Second, if x by 3 is more than 1, implies that x is greater than 3, then series is
Divergent.
divergent. Okay. Third, if x by 3 is equal to 1, that means x is equal to 3, then we cannot conclude anything. About the convergence or divergence. Fine? Hello?
Yes.
Yes, sir.
Okay. Next question.
Test for convergence.
Test for convergence.
Half x
Of
plus
I'm not able to hear you properly.
half x
Half x
plus x square plus 9 upon 8 x cube
9 upon 8
x cube plus x raised to 4 plus 25 by 32 x raised to 5
25 by 32 x raised to 5 and so on. Okay. Now in this series, this is the first term, this is the second term. So you are given summation un as 1 by 2 x raised to 1 x square 9 by 8 x cube x raised to 4 25 by 32 25 है कि 2 raised to 5 25 ही है ना?
Yes sir.
Yes, sir.
Okay. So what we can write?
Sir denominator को 2 के पावर में लिख सकते हैं.
Yes, denominator तो 2 का पावर दिख रहा है x raised to 1
और अपर वाला उसके पावर का स्क्वायर.
यहाँ पे x स्क्वायर है
2 स्क्वायर
तो
2 स्क्वायर बाय 2 स्क्वायर.
अगर मैं 2 स्क्वायर लिखता हूँ यहाँ पे 1 ये 1 स्क्वायर लिख दूं ये 2 स्क्वायर बाई 2 स्क्वायर एक्स स्क्वायर तो ये 3 स्क्वायर बाई 2 क्यूब एक्स क्यूब ये 4 स्क्वायर बाई 2 रेज टू 4 एक्स रेज टू 4 ये 5 स्क्वायर बाई 2 रेज टू 5 एक्स रेज टू 5 and so on. Series goes like this. So now I can very well say what will be my nth term. Nth term will be a first term, second term, first term, second term, third term, fourth term, fifth term. So nth term will be n square
x की पावर n upon
2 raised to n x raised to n. Is it clear?
Yes sir.
Okay. Now, if nth term is this, n plus 1th term will be n plus 1 whole square upon 2 raised to n plus 1 x raised to n plus 1. Now, un plus 1 upon un is n plus 1 whole square 2 raised to n plus 1 x raised to n plus 1. Limit n tending to infinite un plus 1 upon un is limit n tending to infinite n plus 1 whole square upon n square 2 raised to n upon 2 raised to n plus 1 x raised to n plus 1 upon x raised to n. This and this is cancelled, this and this is cancelled. So this is limit n tending to infinite 1 plus 1 by n whole square 1 by 2 x. Now if I substitute in this, so it is 1 plus 0 x by 2 is x by 2. Clear? Now if x by 2 is less than 1 implies that x is less than 2. This implies series is convergent. If x by 2 is greater than 1, that means x is greater than 2, implies that series is divergent. If x by 2 is equal to 1, implies that x is equal to 2, then we cannot conclude about the convergence and divergence of the series. Is the concept clear to all of you? Hello?
Yes, sir.
अच्छा,
Yes, sir.
अब मान लो तुमने कोई बुक उठाई, हो सकता है कि उसमें डी लैम्बर्ट टेस्ट ऐसे ना लिखा हो. हेलो? इसके बजाय उन्होंने ये लिखा हो, लिमिट n टेंडिंग टू इनफाइनाइट un अपॉन un प्लस 1 इज इक्वल टू l. मतलब ये टर्म उल्टा लिखा हो. ठीक है? तो देयर इज नथिंग रॉन्ग इन दिस ऑल्सो, बट होगा क्या कि इसमें वो कहेंगे कि व्हेन l इज लेस देन 1 देन इट इज डाइवर्जेंट. मतलब ये कंक्लूजन जो है उल्टा हो जाता है फिर. हेलो?
Yes, sir.
Second, l is more than 1 then convergent. And third, l is equal to 1 then test fails. Now why I am telling you, because हो सकता है किसी ने बुक उठाया या गूगल किया और उसमें ये स्टेटमेंट लिखा हुआ दिख गया, तो स्टार्ट कर देगा बोलना कि सर हैज taught wrong. So it is not wrong. Both the way it is correct. Okay, now let's proceed further. There is actually plenty of tests are available into the mathematical analysis, but we are going to teach you only 2 tests. The another test is called Cauchy's nth root test. Cauchy's nth root test. Okay. Cauchy's nth root test. हाँ बोलो वंश.
Sir, just a question that when will you upload the last lectures recording of 3rd Feb and last week's?
Can you speak once again? I could not hear you. You could not upload what?
Last week's recording lecture.
Achha,
And
last week recording you are asking me.
yes, sir. And 3rd Feb's recording too.
And
3rd Feb's recording too.
last week recording and first?
Last week recording and before that week, like 3rd Feb.
Achha, okay. Just remind me once at the end of the lecture. I will do that before leaving this class.
Okay, sir.
Okay. Now let's come to the Cauchy's nth root test. What does Cauchy's nth root test says? That if sigma un n is 1 to infinite is an infinite series, okay, and if L is limit n tending to infinite un का nth root, nth term का nth root when n is tending to infinite, then if L is less than 1, then series is convergent. If L is more than 1, series is divergent. So it is same way as I have taught you D-Lambert. वहां पे भी L less than 1 पे series convergent है, यहाँ पे भी L less than 1 पे convergent है. L more than 1 series is divergent. And if L is equal to 1, then test fails. Okay. So if this is the infinite series, this is the infinite series and L is this. This is the infinite series and L is this. Here, what I'm doing, I'm taking the nth root of nth term. Okay, I'm taking the nth root of nth term. Fine? Hello?
Yes, sir.
Now question arises, कहाँ पे D'Alembert apply करेंगे, कहाँ पे ये Cauchy's nth root test apply करेंगे? तो answer for that is where you are finding कि जो तुम्हें nth term है सीरीज का, वो something raised to something के फॉर्म में आ रहा है. ठीक है, जहां पे ये भी n का फंक्शन है और ये भी n का फंक्शन है, then I will suggest you in that you take nth root test ताकि ये दोनों simplify हो सके. Hello?
Yes, sir.
Okay, so looking at what is the nth term of the series, you can decide. There is no such restriction कि आप Cauchy's nth root test ही apply करो यहाँ पे, यहाँ D'Alembert root test apply नहीं हो सकता, ऐसा कुछ नहीं है. अब जहां पे Cauchy's अप्लाई करो वहां D'Alembert भी अप्लाई कर सकते हो, बट क्वेश्चन बनता है कि क्या आप अप्लाई कर पाते हो. तो सिचुएशन मैंने बताई कि अगर तुम्हें कोई एक फंक्शन n का और उस पे भी एक फंक्शन n का ऐसा तुम्हें nth टर्म मिल रहा है सीरीज का, then it will be difficult to apply the D'Alembert test because D'Alembert test talks about the ratio of nth and n plus 1th term. nth और n plus 1th टर्म का रेशियो की बात करता है D'Alembert रेशियो टेस्ट, तो उसमें ये प्रॉब्लम क्रिएट करेगा तुम्हारे लिए. हेलो? सो आई एक्सपेक्ट कि यू कैन जस्ट बाय विजुअलाइजेशन यू कैन डिसाइड कि हाँ यहाँ पे रूट लेना ज्यादा आसान होगा. नाउ इफ आई गो टू द एक्सरसाइज 27, yeah, someone please narrate the first question.
Discuss the convergence of the series.
Discuss the convergence of the series
Summation of 1 upon n raised to n.
1 upon n raised to
n.
n.
सिर्फ n है सर.
n is 1 to infinite. Now देखो ये अब सीधे सीधे साफ साफ दिख रहा है कि un में इंडेक्स में n है, तो un is 1 upon n raised to n.
सर
हाँ बोला.
सिर्फ डिनोमिनेटर पे n का पावर है.
अच्छा, डिनोमिनेटर में n का पावर है. ओके, 1 upon n raised to n. So this is 1 upon n raised to n. Now if I take un का 1 by nth root, so 1 upon n raised to n का 1 by nth root. Okay, so limit n tending to infinite, un raised to 1 by n is limit n tending to infinite 1 by n raised to n ka 1 by nth root. Now this is limit n tending to infinite 1 upon n, because this n and this n multiplied will be 1, and in this if you substitute infinite, 1 by infinite is 0. Since 0 is less than 1 implies that series is convergent. Clear?
Yes, sir.
Okay, let's go to the next one. Yeah, please tell me the next question.
Discuss the convergence of the series.
Discuss the convergence of the series
2 square upon 1 square
2 square upon 1 square
minus 2 upon 1
minus 2 upon 1
raised to minus 1 plus 3 cube upon 2 cube
3 cube upon 2 cube
minus 3 upon 2 whole raised to minus 2
minus 2
plus 4 raised to 4 upon 3 raised to 4 minus 4 upon 3 whole raised to minus 3.
ना इस सीरीज में nth टर्म, तो ये फर्स्ट टर्म है, दिस इज सेकंड टर्म, दिस इज थर्ड टर्म. ओके, व्हेन आई एम राइटिंग nth टर्म, तो फर्स्ट टर्म के लिए यहाँ पे 2 है, तो कैन आई से nth टर्म के लिए यहाँ पे n plus 1 raised to n plus 1 upon n raised to n plus 1 minus n plus 1 upon n raised to minus n, because here it is minus 1, here it is minus 2, here it is minus 3, and so on. So un is this. Fine. Okay, hello.
Yes, sir.
Okay. Now, un raised to 1 by n is n plus 1 raised to n plus 1 upon n raised to n plus 1 this entire raised to 1 by. Okay. So limit n tending to infinite, un raised to 1 by n is limit n tending to infinite 1 plus 1 by n raised to n plus 1 minus 1 plus 1 by n, and this entire raised to minus 1, because this and this will be minus 1. Hello?
Yes, sir.
Okay. What is this limit n tending to infinite 1 plus 1 by n raised to n plus 1? Do you know this is e?
Yes, sir.
Barabar na? So if I take the limit, this is e minus 1. This will be minus 1 raised to minus 1. So 1 upon e minus 1. Fine? Hello? Now anybody knows the value of e? The value of e is 2.7 something.
2.74.
Minus 1 if you do, so 1 upon 1.7 something. 1 upon 1.7 is less than 1, more than 1.
Less.
More than one.
Yes.
Kaun bola more than 1? 1 upon 1.7. So denominator is more than numerator. So definitely this is less than 1. Implies that series is convergent. And I hope you can very easily identify that why I have applied nth root test. Because of this minus n. Hello?
Yes, sir.
Okay. Tell me the next question.
The last question, sir.
This was last?
Yes, sir.
Okay. So your module 3 is over. Now we go to module 4. Okay. Okay. Your next module in your syllabus is matrices. Okay. So I hope you all might have gone through this. Your next module, which is matrices 1. Matrices 1 you are studying here. Matrices 2 you will be studying in semester 2. Okay. Okay. Fine. So let's come to the concept of matrices. Please start. Hello, students.
Yes, sir.
What is matrices? What is matrix? What is matrix?
Arrangement of numbers.
Arrangement of numbers. That's it?
In a square or rectangular form.
Enclosed within square.
Okay. Are you seeing on the back of my location in the photograph over here, camera? Are you seeing that there are benches kept on the back side of my?
Yes, sir.
Yes, sir.
Yes, sir.
Is that a matrix? Is that a matrix or not?
An arrangement of numbers rows and columns.
I could not hear you. What you said? Please speak again.
Arrangement of numbers which includes rows and columns.
Arrangement of numbers in the form of rows and column is called matrix. I'm not denying it. I'm asking you that on the back side of mine, there are benches kept and all are empty benches. Now, is that a matrix or not?
Yes, sir.
Yes,
Yes, sir.
So, what are the numbers over there?
One.
No, there is no number 1 over there. See, matrix is not always the arrangement of numbers in the form of rows and column. If somebody asks you what is matrix, matrix is just the arrangement. Hello?
Yes. Yes, sir.
It could be the arrangement of numbers. It could be the arrangement of functions. It could be arrangement of the people. If it could be arrangement of household thing. It could be arrangement of any damn thing what you can think of. If you are arranging it in the form of rows and columns, that is called a matrix. Hello?
Yes, sir.
Yes, sir.
So anything, you are keeping in the memory of computer something and you are keeping it in the arrangement of rows and columns in the hard disk, that is a matrix. when you give the input to any C program, okay, and you want to run a for loop, तो पहले तुम्हें arrangement create करना पड़ता है कि I goes from where to where. So you create a matrix. Hello?
Yes, sir.
Yes, sir.
Yes, sir.
I hope you all are studying the programming in this semester only, no?
Yes,
Yes,
sir.
sir.
Yes, sir.
Okay. Anybody has the exposure of Python programming?
Array.
Anybody has got the exposure to Python programming? Nahin?
Not yet, sir.
Okay. Okay. No issues. So if you are arranging anything in the form of rows and column, that is called a matrix. Now, the matrix what you are going to study is the matrix of real numbers, because the element what you will be writing into the matrix will be real numbers or complex numbers. But don't keep this notion in your mind कि matrix यही होता है, ऐसा नहीं है. Any arrangement in the form of rows and column is called a matrix. Okay. In fact, if I show you the grid view over here on the screen, now this is a matrix. All of you are shown over here on the screen, computer screen to me in the grid. Okay. And that is a matrix. Students, are you with me?
Yes, sir.
Yes,
Yes,
sir.
sir.
Okay.
Yes, sir.
Okay. Fine. Now, so here I'm defining the matrix of real number and complex number. So if m into n, I'm sorry, real number or complex numbers are arranged then this arrangement is called matrix. If m cross n real number or complex number are arranged in the form of rows and column, then this arrangement is called the matrix. Okay. Matrix are generally represented by capital alphabet. So I'm writing here. So suppose A11, A12, A13, these are the element A1, N, A21, A22, A23, there's A2N, A31, A32, A33, AM1, AM2, AM3, okay, this is the matrix. It has got m rows, 1, 2, 3, m. So m rows are there and it has got n column, 1, 2, 3, n columns. So m rows and n columns. Okay, this is called order of the matrix. Okay, m rows and n columns. So जब भी हम order of matrix की बात करते हैं तो first number represent rows, second number represent columns. In fact, here in the suffix says what I have written A11. So first number उसका row position बताता है कि ये first row में है और second number उसका column position बताता है. Fine? Hello? In fact, I can represent this matrix in a very compact way, Aij, where I goes from 1 to m and j goes from 1 to n. So this, instead of writing this big, I can write only this much. Hello?
Yes, sir.
Yes, sir.
Now I go to kind of matrix. Kind of matrix. So we have first a square matrix. What is a square matrix?
M equals to N.
A matrix in which number of rows
M equal to N.
and number of columns
Are equal.
are equal. Then it is called a square matrix. A matrix in which number of rows and number of columns are equal, then it is called a square matrix. ये scroll क्यों नहीं आ रहा? Just a second. Give me a minute. Okay. Fine. Now, after square matrix, let me go to triangular matrix. Triangular matrix. Triangular matrix. So, triangular में दो तरह की triangular matrix define.
Upper and lower.
Upper triangular.
Lower triangle.
Upper triangular. So a matrix in which all the element below the principal diagonal are 0 is called upper triangular matrix. Second, lower triangular. A matrix in which all the element a matrix in which all the element above the principal diagonal are 0 is called lower triangular matrix. So example अपर ट्रायंगुलर का एग्जांपल देखो मैट्रिक्स में ये प्रिंसिपल डायगोनल एलिमेंट कहलाते हैं. हेलो, दो डायगोनल होते हैं मैट्रिक्स में. दिस इज कॉल्ड प्रिंसिपल डायगोनल. तो अपर ट्रायंगुलर के लिए व्हाट डेफिनेशन इज गिवन कि मैट्रिक्स में अपर ट्रायंगुलर में प्रिंसिपल डायगोनल के नीचे के एलिमेंट 0 है, तो 1 2 3 4 5 6 0 0 0. This is upper triangular matrix. Upper triangular. And if I give 4 5 6 7 8 9 0 0, this is lower triangular. Okay, hello, is it clear?
Sir, triangular matrix is defined for only square matrix.
Yes, triangular matrix is defined for a square matrix. Okay, hello, hello.
Yes, sir.
So this is the principal diagonal element. Here, this is the principal diagonal element. In the lower triangular, principal diagonal के नीचे survive करता है, upper triangular में इसके ऊपर survive करता है. But I'm not saying कि I cannot have 0 over here. I can have 0. I can have 0 here. I can have 0 here. No problem. Still it will be lower triangular. And still it will be upper triangular. डेफिनेशन ये कहती है कि अपर ट्रायंगुलर में प्रिंसिपल डायगोनल के नीचे के ये एलिमेंट श्योरली 0 होने चाहिए, लोअर ट्रायंगुलर में प्रिंसिपल डायगोनल के ऊपर के ये एलिमेंट श्योरली 0 होने चाहिए. दैट इज द डेफिनेशन. इट डज नॉट सेज कि ये एलिमेंट नॉन जीरो होने चाहिए. हेलो हेलो.
Yes, sir.
Yes, sir.
Okay. Now scalar matrix. A matrix in which scalar के पहले I should define diagonal matrix. A matrix in which principal diagonal element are non-zero element whereas all other element
0.
are zero. Example is I give you 1 2 3 0 0 0 0 0 0. So this is a diagonal element, diagonal matrix. Okay. Now scalar matrix. A diagonal matrix. A diagonal matrix in which principal diagonal element
Same.
is a same non-zero element. Example 2 2 2 0 0 0 0 0 0. So this is a scalar matrix. Now identity matrix. Identity matrix is a scalar matrix. It is a scalar matrix in which non-zero element on principal diagonal
1.
is 1. Okay, this is generally represented by identity matrix 1 1 1 0 0 0 0 0 identity matrix. Fine. Now concept comes transpose. If A is any matrix, then by interchanging all its, I'm sorry, oh, suddenly that has stopped working. Okay, what I was saying, if A is any matrix, then by interchanging all its rows, oh, now this is creating problem. Students, be patient. Give me a minute. Is the screen visible to all of you? Hello?
Yes, sir.
Okay. Okay. So I was talking about the matrices. Matrices. Now, क्या define कर रहा था मैं? Transpose. Transpose. So let A be any matrix. Then transpose of A is achieved by interchanging all its rows by its columns, and it is represented by A dash or A transpose. Fine? Hello?
Yes, sir.
Okay. So let A is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. If A is this, and I want to find out A transpose. So all the rows I'm making column. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay. Now, if you notice, this was having the order 3 cross 4, and this is having order 4 cross 3. So how many rows were there? That many columns has become in this. Students, are you with me?
Yes, sir.
Yes, sir.
Yes, sir.
Okay. Now, if A is, I take 1, 2, 3, 4, 5, 6, 7, 8, 9. A square matrix. Okay. And I'm taking its A transpose. So when I take A transpose, I will get 1, 2, 3, 4, 5, 6, 7, 8, 9. Now, one very important thing which you should notice, that when I take the transpose in a square matrix, the principal diagonal element is not changing. This one and this one remain same. These elements which are in the lower triangle has gone in the upper triangle, and the element of upper triangle has gone to the lower triangle. Whereas the principal diagonal element on taking transpose is not changing at all. They are remaining same. Are you with me? What I'm talking?
Yes, sir.
Yes, sir.
Yes, sir.
Okay. Now, properties of the transpose. So first property is A plus B transpose or A minus B transpose is A transpose plus B transpose or A transpose minus B transpose. Second, A into B transpose is B transpose into A transpose. Fine? Hello?
Yes, sir.
Okay. Now, with this concept of transpose, there is a specific definition of symmetric matrix. Symmetric matrix. A square matrix A is said to be symmetric if and only if A transpose is equal to A. मतलब मैट्रिक्स का ट्रांसपोज लेने पे अगर मैट्रिक्स में कोई फर्क ना पड़े, it remains same, then that kind of matrix is called symmetric matrix. Okay, example, if I take A is 1, 2, 3, now this is a symmetric matrix. Because if I take A transpose, then I'm making its first row its first column, second row its second column, third row third column. And by this you can observe that A is same as A transpose. Implies that A is symmetric. Okay, hello?
Yes, sir.
Yes, sir.
Why I have used the square matrix? देखो, दो मैट्रिक्स के इक्वल होने का मतलब होता है, हाँ बोलो बोलो
सर वो अगर ट्रांसपोर्ट लेंगे तो रो नंबर ऑफ रोज और कॉलम चेंज हो जाएंगे, इंटरचेंज हो जाएंगे।
yes absolutely what Himanshu is saying right. जब आप कहते हो कि A ट्रांसपोज इज इक्वल टू A, तो इसका दो मतलब होता है। एक तो दोनों का ऑर्डर सेम होना चाहिए, इक्वल मैट्रिक्स का मतलब दोनों का ऑर्डर सेम होना चाहिए। दूसरा, रिस्पेक्टिव पोजीशन A ट्रांसपोज में और रिस्पेक्टिव पोजीशन A में सेम एलिमेंट होना चाहिए। तो अगर A स्क्वायर नहीं रहेगा तो A ट्रांसपोज लेने पे, मान लो A तुम्हारा 3x2 है, तो A ट्रांसपोज लेने पे 2x3, तो ये ऑर्डर और ये ऑर्डर अलग हो गया। हेलो, तो ये दोनों मैट्रिक्स इक्वल ऑर्डर के नहीं होंगे, तो देयर इज नो क्वेश्चन ऑफ A ट्रांसपोज इज सेम एज A.
Yes, sir.
Symmetricity is defined for square matrix only. Is it clear, Mangesh?
Yes, sir.
Okay. Now, a square matrix A is said to be skew symmetric. A square matrix A is said to be skew symmetric if and only if A transpose is equal to minus of A. Okay. Example, if I make A 0, minus 1, 2, 1, minus 2, 0, minus 3, 3, 0. Now this matrix, if I take its transpose, so 0, minus 1, 2. This is plus 1. 1, 0, minus 3, minus 2, 3, 0. So minus 1 common area. 0, 1, minus 2, minus 1, 0, 3, 2, minus 3, 0. So this is minus of it. A is skew symmetric. Student, can I take a break of 2 minutes?
Yes, sir.
Yes, sir.
Okay.
Yes, sir.
2 minutes by watch. Hello.
Yes, sir.
Yes,
Now let's proceed further. Now, complex matrix. Complex matrix. A matrix in which the elements are complex numbers is called complex matrix. Okay. Now, the matrix of real number के साथ हमारे साथ concept था transpose का. Now there is a concept, complex matrix में concept आता है conjugate transpose. So let A be a square complex matrix. A be a square complex matrix. Then if we replace all its complex entries, या complex element by its respective conjugates, and then on taking transpose, we get the conjugate transpose of A. Conjugate transpose of A. Which is represented by A theta or A star. Okay. For example, suppose I take A is 1 plus I, 2I, 3 minus I, 4 plus 4 minus 5I, 2, 3 minus 2I, and 8, 9, 9 plus 2I. Suppose A is this. So A conjugate is represented by this. A conjugate is A bar. So A bar में क्या करेंगे हम? सारे कॉम्प्लेक्स एंट्री को उनके कॉन्जुगेट से रिप्लेस कर देंगे. कॉन्जुगेट कैसे मिलता है? इमेजिनरी पार्ट का साइन चेंज कर देंगे. This is 9 minus 2. So this is A conjugate. Now
Transpose.
Conjugate का transpose, if I calculate, that is 1 minus I, 2I, 3 plus I, 4 plus 5I, 2, 3 plus 2I, 8, 9, 9 minus 2I. Fine? Hello?
Yes, sir.
So this conjugate transpose is represented as A theta or A star. Now, properties of A theta. First property is A plus minus B theta is A theta, plus है तो plus, minus है तो minus, B theta. Second, A into B theta,
B theta into A theta.
B theta into A theta. Okay. Now, there's a definition called Hermitian matrix. Hermitian matrix. A complex square matrix A is said to be Hermitian. A complex square matrix A is said to be Hermitian if and only if A theta is same as A. Complex square matrix. अभी देखो ये it's quite analogous definition of symmetric matrix. Symmetric matrix में क्या कह रहे थे आप? A square matrix A is said to be symmetric if A transpose is equal to A. यहाँ Hermitian में आप कह रहे हो complex square matrix A is said to be Hermitian if and only if A theta is equal to A. मतलब Hermitian is a similar concept for complex matrix as symmetric is a concept for real matrix. Agree?
Yes, sir.
Now, example, if I take A is 1, 2 minus I, 2 plus I, minus I, 2, 3 minus I, 3 plus I, 4. This matrix is Hermitian. इसका अगर मैं A conjugate निकालता हूं, so I'll get 1, 2 plus I, minus I, 2 minus I, 2, 3 plus I, 3 minus I, 4. A conjugate का transpose, that is 1, 2 plus I, minus I, 2 minus I, 2, 3 plus I, 3 minus I, 4. Okay, there's A theta. Now, if you look at A conjugate transpose is same as A, implies that A is Hermitian.
Yes, sir.
Okay.
Hello, sir.
हाँ बोलो.
Sir, can you scroll down to the conjugate transpose matrix wala part?
Yes.
Sir, conjugate transpose square matrix होना compulsory है?
नहीं समझा मैं तुम्हारा डाउट. कॉन्जुगेट ट्रांसपोज स्क्वायर मैट्रिक्स में कंपलसरी है मतलब कॉन्जुगेट ट्रांसपोज नहीं जरूरी नहीं है. कॉन्जुगेट ट्रांसपोज तुम किसी का भी निकाल सकते हो. हेलो, वहां स्क्वायर मैट्रिक्स जरूरी नहीं है, बट हर्मिशियन में वो जरूरी है कि कॉन्जुगेट ट्रांसपोज शुड बी सेम एज ए. तो यहाँ पे स्क्वायर मैट्रिक्स होना चाहिए. कॉन्जुगेट ट्रांसपोज जरूरी नहीं है कि स्क्वायर मैट्रिक्स का, आप किसी भी मैट्रिक्स का कॉन्जुगेट ट्रांसपोज निकाल सकते हो.
Okay, sir.
Okay.
Thank you, sir.
Now skew Hermitian matrix. A complex square matrix is said to be skew Hermitian if and only if A theta is equal to minus of A. A complex square matrix is said to be skew Hermitian if and only if A theta is equal to minus of A. Now example, if I take A 0 minus I 0, then A conjugate will be what? 0 I 0. A conjugate का transpose is what? 0 I. If I take minus 1 common, it's 0 minus I 0. So this implies A conjugate ka transpose is equal to minus of A. A is skew Hermitian.
Yes, sir.
Okay. Now I can go to your exercise, that is exercise 28. पढ़ो क्या है first question? Exercise 28 first question पढ़ो. Student, hello. Okay, is this the first question?
Yes, sir.
तो अभी तक चुपचाप क्यों बैठे थे? तुमको लगा सर को मिलेगा नहीं? हाँ? अच्छा. Let's come to the solution of it. They are saying show that the diagonal element of a Hermitian matrix is purely real. Diagonal element of skew Hermitian matrix are either purely imaginary or zero. ठीक है? So let A is equal to Aij be a Hermitian matrix. Okay, let A is equal to Aij. ठीक है, ये पहले मैं ये पार्ट कर रहा हूं. इसमें एक्चुअली दो क्वेश्चन है. शो दैट द डायगोनल एलिमेंट ऑफ हर्मिशियन मैट्रिक्स इज प्योरली रियल. पहले ये, फिर एंड वाला पार्ट आगे बाद में करते हैं. ठीक है, तो ये हर्मिशियन मैट्रिक्स मैंने मान लिया. हेलो.
Yes, sir.
Yes, sir.
ओके, सो अगर ये हर्मिशियन है तो A थीटा विल बी सेम एज A.
Yes, sir.
That means Aij theta is equal to Aij.
Yes, sir.
Okay. This implies Aij conjugate transpose is same as Aij. Fine?
Yes, sir.
Yes, sir.
For principal diagonal element, उन्होंने प्रिंसिपल डायगोनल एलिमेंट या डायगोनल एलिमेंट लिखा है. ठीक है, फॉर प्रिंसिपल डायगोनल एलिमेंट I इज इक्वल टू J, क्योंकि उनका रो पोजीशन कॉलम पोजीशन दोनों सेम होता है प्रिंसिपल डायगोनल के एलिमेंट का. A11, A22, A33, तो उनका
Yes,
रो
sir.
पोजीशन कॉलम पोजीशन सेम होगा प्रिंसिपल डायगोनल का. ठीक है, हेलो.
Yes, sir.
Yes, sir.
सो नाउ अब यहां पे तो मैट्रिक्स से मैं एलिमेंट पे जा रहा हूं. यहां मैट्रिक्स था, नाउ आई एम गोइंग टू द एलिमेंट्स. Okay, the moment I decide कि now I go to the element, I will not write a square bracket, I will write small bracket. and this is equal to AII. Fine. Hello.
Yes, sir.
Okay. Now, one more thing I have discussed when I introduced you transpose, कि diagonal element का transpose में कुछ change नहीं होता, वो वही का वही रहता है.
Yes, sir.
Diagonal element fix रहते हैं, वो change नहीं होते transpose लेने पे. So AII will be equal to AII. Conjugate will be there. Conjugate will be there. Conjugate is there. AII conjugate is equal to AI. Barabar? Hello?
Yes, sir. Yes.
Yes, sir.
Now, can any one of you tell me when it is possible a complex number is equal to its own conjugate?
No, sir.
It is possible if it is purely real number.
Yes, sir.
अगर कॉम्प्लेक्स नंबर ऐसा है जिसका इमेजिनरी पार्ट है ही नहीं, वो प्योरली रियल है, तो वो अपने कॉन्जुगेट के बराबर होगा. ठीक है, या तो तुम वैसे ही कंक्लूड कर दो यहाँ पे, या फिर यू कैन से इन दिस वे लेट AII is x plus IY, एक कॉम्प्लेक्स नंबर. देन फ्रॉम स्टार I can say x minus IY, x plus IY. Now this x and x gets cancelled, implies that 2IY is 0, implies that y is 0. And this says, implies that AII is equal to x is purely real number. So principal diagonal element of a Hermitian matrix are purely real numbers. So first part I proved. So the diagonal. हाँ बोला.
सर आपने जो यहाँ पे बताया उसके अंदर जो रियल पार्ट है वो इक्वल होना चाहिए, तो ही y इक्वल टू 0 होगा ना.
Vineet, can you repeat your doubt, please?
सर जो आपने बताया लेट AII इक्वल्स टू x प्लस IY दिस पार्ट, सर उसके अंदर जो रियल पार्ट है जो x वो इक्वल होगा तभी जाके y इक्वल्स टू 0 कंक्लूड होगा ना.
अभी ये देखो, तुमने हर्मिशियन की बात की, हर्मिशियन की बात की, ठीक है. हर्मिशियन हो रहा है तो ये फॉलो हो रहा है, ये फॉलो हो रहा है, ये भी फॉलो हो रहा है और ये भी फॉलो हो रहा है. If A is Hermitian, this much is there. Fine. Hello?
Yes, sir.
Now, a principal diagonal element का conjugate अपने ही element के बराबर है. ये तुम प्रूफ कर दे रहे हो कि अगर हर्मिशियन है तो उसका conjugate principal diagonal element का अपने ही element के बराबर है. तो यहाँ पे मैं सीधे कंक्लूड कर सकता हूँ कि वो प्योरली रियल होगा, या फिर उसको मैथमेटिकली ऐसे दिखा सकता हूँ कि सपोज करो कि प्रिंसिपल डायगोनल का वो एलिमेंट एक कॉम्प्लेक्स नंबर है, तो कोई कॉम्प्लेक्स नंबर का कॉन्जुगेट अपने ही बराबर तब हो सकता है जब उसका इमेजिनरी पार्ट 0 हो. दैट मींस दैट प्रिंसिपल डायगोनल एलिमेंट इज प्योरली रियल.
ओके सर.
ओके.
यस.
नाउ आई गो टू द सेकंड पार्ट ऑफ द क्वेश्चन. Let A be the skew Hermitian. क्वेश्चन ये है सेकंड पार्ट में कि प्रिंसिपल डायगोनल एलिमेंट ऑफ skew Hermitian matrix are either purely imaginary or 0. ये प्रूफ करना है. So let A be skew Hermitian. Okay. So what is the definition of skew Hermitian? A theta is equal to minus of
A.
Okay. That means A conjugate transpose is equal to minus of A. This implies Aij conjugate transpose is Aij. Aij conjugate transpose is minus Aij. Fine. Hello.
Yes, sir. Yes, sir.
Okay. Now, for principal diagonal element, I is equal to j. So ai conjugate transpose is minus ai. ओके बट फिर से प्रिंसिपल डायगोनल का एलिमेंट है, ट्रांसपोज कुछ होगा नहीं, तो ए आई कॉन्जुगेट इज माइनस ए आई.
Yes, sir.
बराबर. If a, this is star, if ai is 0, then star is satisfied. Okay, i.e. principal diagonal element is 0. If ai is non-zero, ये अगर 0 है तो भाई 0 का कॉन्जुगेट इज इक्वल टू -0, तो ये सेटिस्फाई हो जाएगा स्टार. यस और नो?
Yes, sir. Yes.
तो एक केस हो गया कि प्रिंसिपल डायगोनल एलिमेंट 0 हो सकता है. मान लो कि प्रिंसिपल डायगोनल एलिमेंट 0 नहीं है, तब क्या होगा? तो उस केस में अगर ai इज नॉट 0, then let ai is x plus iy, then ai bar is x minus iy. Therefore, from star, what I get? From star I get
X minus iy.
x minus iy is minus x plus iy. So x minus iy is minus x minus iy. Minus iy is cancelled. So it is 2x is equal to 0, implies that x is equal to 0. When I have x is equal to 0, implies that ai is iy. It is purely imaginary. This implies the principal diagonal element of a skew Hermitian matrix is either 0 or purely imaginary. Either 0 यहां प्रूफ किया मैंने, and purely imaginary. Is it clear?
Yes, sir. Clear.
Yes, sir.
Okay. Now let's take it second question. Somebody tell me what is the second question is.
Express matrix A as the sum of.
Express matrix A as sum of
Symmetric and skew symmetric matrix.
And skew symmetric matrix.
Where brackets 1, 2, 3, 4, 5, 6, 7, 8, 9.
Where A
like 2 into 3. So 2 into 3 के order.
A का order 2 into 3 है, क्या कह रहे हो?
3 into 3 सर.
नहीं समझा क्या?
Totally 1, 2, 3 फिर नेक्स्ट
A 1 2 3 हाँ
4 5 6 नीचे।
तो बोलो ना फर्स्ट रो 1 2 3, सेकेंड रो 4 5 6, थर्ड रो क्या है?
7 8 9
हाँ
7 8 9
7 8 9। ओके, एक रिजल्ट है जो मैं प्रूफ करता हूं एंड देन आई विल कम टू दिस क्वेश्चन। वो कहता है every square matrix can uniquely be expressed as sum of a symmetric and skew symmetric matrix। हर एक स्क्वायर मैट्रिक्स को हम यूनिकली एक्सप्रेस कर सकते हैं एज सम ऑफ अ सिमेट्रिक एंड स्क्यू सिमेट्रिक मैट्रिक्स। Every square matrix can uniquely be expressed as sum of a symmetric and skew symmetric matrix। Okay, पहले इसको प्रूफ कर लेते हैं, then we will go to the question what is asked to me। So let A be a square matrix। ठीक है, हेलो, all of you please pay attention, क्योंकि क्वेश्चन है एवरी स्क्वायर मैट्रिक्स एंड इफ यू डोंट अंडरस्टैंड दिस यू विल नॉट बी एबल टू सॉल्व द प्रीवियस क्वेश्चन व्हिच इज गिवन बेस्ड ऑन दिस रिजल्ट। सो लेट ए बी अ स्क्वायर मैट्रिक्स, देन आई कैन राइट ए इज इक्वल टू 1/2 ए प्लस ए ट्रांसपोज प्लस 1/2 A minus A transpose। That's simple algebra। Half of A transpose minus half of A transpose cancel हो जाएगा, half of A can be written as A। Clear?
Yes sir।
अच्छा, अब second important thing is कि आपको ये याद रहना चाहिए, when you want to express, जब आप किसी मैट्रिक्स ए को एज अ सिमेट्रिक एंड स्क्यू सिमेट्रिक मैट्रिक्स एक्सप्रेस करना चाहते हो, तो ये ए को कैसे हमने ब्रेक किया था, ये फर्स्ट लाइन आपको याद रहनी चाहिए। अगर आपको याद नहीं है तो आप एग्जाम में बैठ के सारे लाइट पंखा गिन डालोगे, कुछ नहीं होगा। ठीक है, अभी आगे बढ़ते हैं। So A can be written as this। Okay, let 1/2 A plus A transpose, इसको एक मैट्रिक्स बना देते हैं जिसका नाम दे देते हैं P, and 1/2 A minus A transpose is Q। Then my A will be written as P plus Q। Now I claim that P is symmetric। देखते हैं, P is symmetric। So symmetric को प्रूफ करने के लिए P ट्रांसपोज निकालते हैं। P ट्रांसपोज अगर P के बराबर आ जाए तो आई विल से यस इट इज ट्रू। P ट्रांसपोज मतलब 1/2 A प्लस A ट्रांसपोज का ट्रांसपोज, that is 1/2 A ट्रांसपोज प्लस A ट्रांसपोज का ट्रांसपोज। तो ट्रांसपोज का ट्रांसपोज इज अगेन A। Are you with me, students?
Yes sir। Yes।
So this is A again। So this is again I got P।
Yes sir।
When I took P transpose I got P, implies that P is symmetric।
Symmetric।
Now I claim that Q is, this Q is skew symmetric। Q is skew symmetric. Okay, so Q transpose is 1 by 2 A minus A transpose ka transpose. That is 1 by 2 A transpose minus A transpose ka transpose. A transpose minus A. So Q transpose is minus 1 by 2 A minus A transpose minus Q. Q transpose is minus Q. Implies that Q is
Skew symmetric.
skew symmetric. Q is skew symmetric. Now, can I say that since हर एक A को आप ऐसे लिख सकते हो, हेलो हेलो,
Yes, sir.
हर एक मैट्रिक्स A को आप ऐसे ब्रेक कर सकते हो जैसे मैंने ये ब्रेक किया हुआ है. Every matrix A you can break in this way plus this way. ठीक है? Hello.
Yes, sir.
Yes, sir.
If every matrix A can be broken as these two, and मैंने प्रूफ किया कि ये सिमेट्रिक है और ये स्क्यू सिमेट्रिक है, तो now can I say कि every matrix A can be written as sum of a symmetric matrix and skew symmetric matrix? Can I conclude that?
Yes, sir.
Yes, sir.
Implies that every square matrix can be expressed as sum of a symmetric and skew symmetric matrix. Now I will prove that ये जो symmetric matrix है और ये जो skew symmetric matrix है, ये यूनिक होती है. यूनिक मतलब किसी एक पर्टिकुलर A के लिए ये यूनिक होगा. ऐसा नहीं है कि आपको A के लिए 2-3 सिमेट्रिक मिल जाएगी और 2-3 स्क्यू सिमेट्रिक जिनके कॉम्बिनेशन में A को लिखा जा सकता है. ऐसा नहीं है. किसी एक A के लिए एक यूनिक सिमेट्रिक मिलेगी और एक यूनिक स्क्यू सिमेट्रिक मिलेगी. दैट इज द वर्ड यूनिकली यूज्ड ओवर हियर. हेलो.
Yes, sir.
Yes, sir.
यूनिकनेस आई विल प्रूव. मैथमेटिक्स में कोई रिजल्ट प्रूफ करने का दो तरीका होता है. एक तो भाई कोई लॉजिक से आप प्रूफ कर दो, ठीक है, कोई लॉजिक से आप वो चीज प्रूफ कर दो जो प्रूफ करना है. दूसरा, जो चीज प्रूफ करना है उसका निगेशन मान लो. निगेशन मतलब उसका उल्टा मान लो और उसका उल्टा मान के दिखा दो कि ये मानने से कुछ गड़बड़ हो रहा है, तो फिर जो हम प्रूफ करना चाहते हैं वो करेक्ट है. आर यू विथ मी?
हाँ, sir.
So let P and Q are not unique. मान लिया. Then there exists another matrix, another symmetric matrix. Symmetric matrix B and another skew symmetric matrix Q such that A is equal to another skew symmetric matrix C लेंगे ना, sorry Q तो पहले ही ले लिया, another skew symmetric matrix C such that A is equal to B plus C. बराबर?
Yes, sir.
So what will be A transpose? That will be B plus C transpose, and that is B transpose plus C transpose.
C transpose.
A transpose is B is symmetric, so B, and C is skew symmetric, so minus C.
Minus C.
Okay, so if I add 1 and 2, 1 plus 2, so A plus A transpose is 2B, so B is 1 by 2 A plus A transpose. So it is not different than P. तो जो माना है तुमने क्या अंदर है, तो B is same as P आ रहा है. And if I do 1 minus 2, then I get A minus A transpose is 2C. So C is 1 by 2 A minus A transpose. So C is Q. Implies that P and Q are unique. So now ये जो word हमने use किया, every square matrix can be expressed as, can be uniquely expressed, यहाँ पे हम add कर सकते हैं as sum of a symmetric and skew symmetric matrix. कळलं का?
Yes, sir.
Yes, sir.
Okay.
Yes, sir.
Okay. Now let's come to this question. So ये A दिया है. अगर मैं इसका सिमेट्रिक और स्क्यू सिमेट्रिक में एक्सप्रेस करना चाहता हूं, okay, so I will find out A transpose. I have to construct this. So A is, now let's come to that question. A is 1, 2, 3, 4, 5, 6, 7, 8, 9. So A transpose is what? 1, 2, 3, 4, 5, 6, 7, 8, 9. Now if I do A plus A transpose, so if I start adding, I will be getting 2, 6, 10, 6, 10, 14, 10, 14, 18. Okay. So 1 by 2 time A plus A transpose is 1, 3, 5, 3, 5, 7, 5, 7, 9. Okay. A minus A transpose, if I do, so it is 0, minus 2, minus 4, 2, 0, minus 2, 4, 2, 0. So 1 by 2 A minus A transpose is 0, minus 1, minus 2, 1, 0, minus 1. हाँ बोलो. Okay. Now I can write A. It is 1, 2, 3, 4, 5, 6, 7, 8, 9. I can write A as 1, 3, 5, 3, 5, 7, 5, 7, 9 plus 0, minus 1, minus 2, 1, 0, minus 1, 2, 1, 0. Okay. So I'm expressing this A as sum of a symmetric. This is symmetric matrix. and this is
Skew symmetric.
symmetric matrix and skew symmetric matrix. Okay, so we expressed A as sum of a symmetric and skew symmetric matrix. Now tell me what is the next question.
Done.
So that exercise is done. Now shall we go to the next exercise? Or it's a break time?
सर
हाँ बोला.
सर इसके अंदर यूनिकनेस क्या था वो थोड़ा एक्सप्लेन करो ना.
इसके अंदर
यूनिकनेस हमने यूनिकली
एक सेकंड यार. हाँ बोलो इसके अंदर क्या.
सर वो यूनिकनेस स्क्यू सिमेट्रिक और सिमेट्रिक मैट्रिक्स यूनिक रहता है आपने बोला था.
हाँ तो यहाँ प्रूफ किया मैंने, रिजल्ट में वो प्रूफ किया है. मतलब यूनिकनेस का मतलब ये है कि जैसे देखो ये तुम्हारी मैट्रिक्स है. हेलो.
यस सर.
इसको जब तुम एक सिमेट्रिक और एक स्क्यू सिमेट्रिक के फॉर्म में एक्सप्रेस कर रहे हो इन द फॉर्म ऑफ एडिशन ऑफ देम, तो आपको इस मैट्रिक्स के लिए एक ही सिमेट्रिक और एक ही स्क्यू सिमेट्रिक मिलेगी. ऐसा नहीं है कि आपको ये मैट्रिक्स आपकी है और you can get many symmetric and many skew symmetric matrix. That case will not arise. It will be for this matrix there will be a unique symmetric and unique skew symmetric जिनके एडिशन के फॉर्म में आप एक को लिख सकते हो. That's what the result taught. तो यूनिकनेस मैंने प्रूफ किया in the result, but वो क्वेश्चन में थोड़ा हम यूनिकनेस दिखाएंगे.
Yes.
Okay.
Yes sir.
Okay. So now is it break time? Yes.
सर
हाँ बोला.
सर वो लेक्चर अपलोड करना था.
हाँ okay once I will upload it just.
Yes sir, last week and before last week both lecture.
Okay.
Yes sir.
How many tutorials I had given you student up till now? Two. Okay, so I'll give you 3 and 4 today in the GC. Fine.
Yes sir. Sir, can you send today's PPT? PDF?
Yes. The PDF I will share immediately.
Okay sir.
In the WhatsApp group. Okay. So shall I end this meeting? We'll meet at 2 o'clock again.
Yes sir.
Yes sir.
Yes sir.
Okay.